Hello everyone, welcome back to our channel. Today we are going to understand the world of waveform, specifically exploring three key concepts of the waveform, which are frequency, amplitude and phase. Okay, so of course you can see here this is the diagram of a waveform, which including many terms that are amplitude, wavelength, frequency, phase, right? So first of all, we are trying to get out of the confusion between frequency and wavelength. Wavelength and frequency are not the same. These are different. Okay, so let's get started from the wavelength and then we'll understand the frequency, amplitude and phase. So first let's see what is wavelength, right? So you can see here in this diagram this waveform in this color started from the 0 to 1 peak, right? Then again 0 and start to goes in a negative side and then comes again to the positive side. So here is the 1 peak of the waveform at the positive wave. From the negative to comes to the positive, the peak. So it could be say peak to peak, right? So this is the repeating waveform, but one here is considered at the y-axis 5 voltage and the x-axis time with respect to time. We know what is the voltage. The force of the charges is called the voltage, right? So applying force is 5 voltage at the 1 peak. The highest threshold, or you can say highest voltage, is 5. So it is called the peak one, right? So first peak at the positive side and another peak through the negative and comes to the positive and the peak, right? So first positive peak to the another positive peak, the distance, or you can say the duration between this two wave peak, it's called the wavelength. As well as you can see the wavelength of the negative cycle, negative waveform also. Here is a minus 5 voltage in the negative side. This is the first peak of the minus 5 voltage, and here you can say the upper line of this peak, which is the next negative wave, right? So this is peak to peak, but in the negative cycle. So you can say the duration between two peak of the negative cycle, it's called the wavelength, right? So do not confuse, started from the 0 at the 5 voltage plus 5 to repeating the another 5 voltage of the waveform. This is the repeating, right? This is the first 5 voltage A and this is the another 5 voltage B. So this A and B duration is called the wavelength. Okay, now let's see the frequency, but before we start the frequency, let's see the symbol of the wavelength is lambda. As you can see here, this is the upside down y, right, letter y. So this is called the lambda and this is the symbol of the wavelength. So as you can see here, the wavelength corresponding to distance between each repeating point in the wave. Each repeating point, either it's on a positive cycle, either it's in a negative cycle, is considered by the peak to peak voltage, or you can consider the upper side and lower side. It is repeating up here to here, and the duration between that, it's called the wavelength. Now let's jump on the frequency. Of course, in this figure, the frequency starts from the 0, right, as the wavelength, but as you can see, this is the positive one cycle and this one is minus 5 voltage, which is negative cycle, and this cycle positive and negative completed the one waveform, or you can say one cycle, right? So from the 0 goes to the positive and then negative and then comes to the 0, and this is called the complete cycle, right? And I'm not talking about the peak, I'm just talking about the cycle. This is the positive one and this is the negative one, and complete to the 0. And this duration, or you can say this time with respect to time, and this waveform, it's called the frequency, right? So you can say here that frequency refers to the number of cycle. Frequency refers the number of cycle a wave completes in given unit time. This is the one cycle. 0, this is positive waveform, and from the 0, which is negative waveform, it is called the complete one cycle. And this is repeating again from the 0, this is the positive one, and comes to 0, and this is the negative one. So complete cycle 0 to 0. And this per unit time, or you can say the with respect to time, it's called the frequency. Here is not considered any peak or the positive or the negative. It's considered by the positive peak and negative peak together and completed or repeating the cycle. It's called the frequency, right? So again, the wavelength is peak to peak duration, and the frequency is cycle to cycle duration of the waveform, right? Now let's see frequency, which is high frequency and low frequency, right? You can see here, now you know what is the frequency, right? At the blue line, it's called the lambda. What is that? It is the wavelength. If the duration of the peak to peak is high, or you can say more distance, then you can say the wavelength is high, right? But the duration is going to peak duration is going to decrease, right? So it's going to, what is that? It is the low wavelength, right? Now let's consider about the frequency. Here the high frequency, why it's called the high frequency here? Because the duration between the peak to peak is going to decrease, and then the increase the waveform. Why? Because you can see here the positive cycle and the negative cycle. You can say start from the positive one and then negative and again the positive, right? So here start, as I say here, the positive waveform and the negative waveform, it's called the frequency duration, right? Now see here, let's start from the 1. Start from the 1 and then 2. This is the frequency. But here see the duration of with respect to time. Start from the 1 and 2. As you compare the first figure to the second figure, here 2 comes up here in the 2. Now go to the straight line for 2, and here is 3. So duration is expanded, right? So expanded duration, which is the what? Wavelength. But the duration is going to be decreased up here by the complete cycle. This is the one complete cycle, 1 to 2. Right? Then 2 to 3, it's complete cycle, but the duration is going to be decreased. If the duration is going to be decreased, then it's called the high frequency and the low wavelength. But the duration is going to be increased, right, with respect to time. That you can say the wavelength is going to be high and the frequency is low. You can also experiment in your phone that you recorded something in a fast speech, or you can say fast vocal. That frequency is going to be high. But if you just do with the low speech, just speak low down, right? And then the wavelength is going to be increased, not frequency. You can do that experiment also. So this is the wavelength and frequency with respect to duration. Duration is going to be decreased, then frequency is going to be increased, and duration is going to be increase such as what? With respect to time. See here, the duration is more, but here the duration is less. So less duration, frequency is high. More duration, frequency is low. Less duration, here is, you can say, less duration, wavelength is going to be what? Low. Duration is going to be decrease, then frequency is going to be high. We can understand by the formula. Okay, F is equal to C by lambda. Okay, what is that C? You know, the C is what? The speed of the light. We can say C is the reference waveform. Okay. Next, here you can see that here 3 hertz, 6 hertz and 12 hertz. What is hertz? This is the unit of the frequency. As I said, Hz, right? Hertz, the one scientist who declared or defined the frequency, and as per his name, as per the scientist's name, the unit of frequency is hertz, right? You can see here, this is the low frequency. Why it is low? Duration is more, right? With respect to time, the duration is more. That's why it's 3 hertz. Now increase the frequency, which is 6 hertz. Now duration of the complete cycle is decreasing, right? See, this is the one waveform, from here positive and from here to negative. So duration is decreasing, right? If the duration is decreasing, frequency is going to be increased. Now see the third one, the green one. Duration is again more decreasing with respect to time or per unit time. So frequency is increasing, right? Which is 12 hertz. So you can say frequency and wavelength are opposite to each other, or you can say the directly proportional is frequency and inversely proportional to the wavelength, right? So duration is increasing, then what? Frequency is decreasing, but wavelength is going to be increased. Okay, if the duration is decreasing, then frequency is increasing. You understand it? So this is the inversely proportional. Frequency and wavelength are inversely proportional to each other. Now let's see the equation of it. Wavelength is speed of light. Okay, speed of light is a reference that we are taking it. As we know, the C, speed of light C is the highest frequency, or you can say waveform, that we measured in entire universe. The fastest waveform, or you can say fastest frequency to speed of the light, nothing else, right? So we can take the reference of speed of light and consider the frequency and wavelength. If frequency is increased, then wavelength is going to be decreased, and if frequency is decreased, then wavelength is going to be increased. As you can see here, the duration of this red waveform, you can say the signal, the red one, duration is increased, right? Then we can say the wavelength is increased, but the frequency is decreasing. As duration is going to be down in the sense suppressing, right? If the duration is going to be increase in the sense is going to be fast. As you can say, the first total repeating waveform and the blue one, the repeating waveform, duration is decreasing, right? So in this case, frequency is increasing, but wavelength is decreasing. I hope you understand it. Now let's see again the equation. Lambda is equal to c by f, and f is equal to c by lambda. Frequency is going to be increased, then wavelength is going to be decreased. And as I say, the practical you can do it by the record, or open your phone and cell phone and just open the recording. You can see the waveform. If you speaking fast, then frequency is going to be increased, but you are going to be speak slow or in a down way, then wavelength is going to be wavelength is going to be increased, but not frequency, right? Now next is what? Phase. What is phase? Phase is nothing but the changing the angle of the waveform. You can see here the waveform is in a you can say not this one, the last one. Pi by 2 means what? 90 degree, right? 90 sine. Why it's sine here? Because it start from the 0. Okay, as we understood, the sine wave start from the 0 and cos wave start from the upper side, or the 5 voltage, or you can say any other number. The frequency f1 and f2, you can say the sine this f1 and f2 is going to be changed with respect to the waveform, and this waveform is changing by the phase. Changing by the phase in the sense changing the angle of it. The red one and the blue one, this is the f1 and f2, right? So this f1 and f2 going to be combined in the third one by the changing the angle. So you can see here the waveform shape is changed, right? So this is the comparison by the amplitude and the frequency by the changing the angle. It's called the phase, right? We will see the amplitude also. Amplitude is what? The height of the frequency at the either the positive side and the negative side. The height of the frequency, it's called the amplitude, right? You can see here up. Amplitude is what? A 5 voltage. Plus phi and minus phi. So this is the amplitude. The height from the 0 with respect to, here is not a time or anything, just by the graphical, from the 0 to high pitch, from the 0 to low pitch. The highest one and the lowest one, it's called the amplitude of the waveform. So again, see the phase here. Now you combine f1 and f2, the changing in the phase or changing in the angle, it's called the phase, right? See here. Now angle 0, 90, 180, 270, 360, right? 0, pi by 2, pi, 3 pi by 2 and 2 pi. You know that, right? In the circle. Now consider the plane and the waveform. It could be the 90 degree up here. But in the blue line you can say 90 up here, then comes in 270 and then comes up at the 90 degree, right? But in the red one you can say started 0 by the 90. Here is 90 degree, but it started by the 90 and then comes to 360 and then comes to 180. So changing the angle, just consider the circle of the angles, right? It comes from the 0 to 90 and some frequency started from the 90 and then comes to 360 or the 270. So angles would be changed, right? So the phase involves a relationship between the position of the amplitude crest to throw of two waveform. Position is going to be changed. Now blue one is started from the 0, but the red one is started from the 90, right? Blue one comes to the negative cycle. Negative waveform is 270, but the red one is started from the 360, 2 pi. So the changing of the waveform with respect to the angle, so it's called the phase, right? The phase involves the relationship between the position of the amplitude. Amplitude is there by applying the height, or you can say the highest peak, 5 voltage plus 5 to minus 5. It's called the height of the waveform. It's called the amplitude, right? But the amplitude start from the 0, the amplitude start from the 90 or pi or 270, like that. So it's changing the angles. It's called the what? Phase. Now what is the symbol of phase? It's called the psi. You can see here. This is the waveform. Some in a book says 5. Some in a book says psi. PSI. Right? So this is the symbol, or you called psi. Phase. This is the symbol. Okay, now let's revise this all three topic. Frequency is defined as the number of waves that pass a certain point in 1 second, right? Here is considered the wave. Wave is what? Not a repeating cycle, is complete cycle from 0 to positive, then negative, and then comes 0. Then it's called the complete cycle. Okay, per unit time, or you can say 1 second. Then it's called the frequency, and which is called hertz. The unit is hertz, right? The amplitude is maximum displacement, or the distance moved by the point or the vibrating body on a wave measured from the equilibrium position. From the 0, the maximum displacement at the upper side, at the positive and the negative side, plus 5v and minus 5 we saw in the figure, right? So this is called the amplitude. And the phase is what? Phase is the position of the wave at a point in the time and instant waveform cycle, right? Now you can see here the position of the waveform is going to be changed with respect to the angle, right? So if the first waveform start from the 0, another waveform start from the 90. So the difference between two waveform is 90. So it's called the phase of the two waveform cycle. It's 90. You can say like that, right? That's it from now. I hope you understand frequency, amplitude, and the phase. Do not confuse about the frequency and wavelength. It's always inversely proportional to each other. Okay, frequency increase, then wavelength is going to be decreased with respect to the time. Duration is more, then wavelength is more, but frequency is less. Okay, if the duration is less, then frequency is increasing and wavelength is going to be decreasing. Do not confuse on it, right? Now phase is what? We are going to change the waveform with respect to the angle, then it's called the phase. Frequency unit is hertz, phase unit is phi, or you can say psi, right? So this is the only about the frequency, amplitude, and phase. I hope you understand it. Thank you. See you next time.